In this video, we're going to be looking at factoring by grouping. And factoring by grouping is something that can be used, we talk about the AC method for factoring trinomials, and the AC method is actually based in grouping. So we're going to actually look at how to factor with grouping when you have terms like this. So in each of these, you've got four terms. These are expressions. Remember, they're not equations. Equations is when you actually have two equal values. There's an equal sign. It's an equation. You can solve, manipulate, move. Here we just have expressions. So let's factor by grouping. When you do grouping, you want to actually group terms. That's what we're going to be doing. And sometimes you have to rearrange the terms to get the ideal group for you. But let's not do that unless we have to. So let's look at the first one. I've got 12a cubed minus 9a squared. And I'm going to group those two together, and I'm going to group these two together, 4a minus 3. When you do grouping, normally you have four terms. This is the most common example that you're going to see. You're going to group two terms together, and you're going to group the other two terms together. And between those, individually, within the groups, we're going to look for GCFs, greatest common factors. So let's look at this part. What is the greatest common factor between 12a cubed and a squared? Well, first of all, I can factor out an a squared because I've got a cubed here and a squared here. So if I want to factor out the variable portion, I can factor out an a squared. And then for 12 and 9, the greatest common factor between those two guys is 3. So I'm going to factor out a 3a squared. When I do that, what is 12 divided by 3? Because remember, when you're factoring means multiplying. So when I'm factoring out, I'm dividing. So 12 divided by 3 leaves me with 4. And a cubed divided by a squared leaves me with a. So I'm left with 4a when I factor this out of here. How about factoring the 3a squared out of the negative 9a squared? Well, 9 divided by 3, and it's negative, leaves me with a negative 3. And if I factor a squared out of a squared, that just leaves me with 1. So I'm left with 4a minus 3. That's the first group factor. So let's look at the second group. Is there anything I can factor out of 4a and negative 3? Actually, no, there isn't. But what number can be a factor of anything? 1, right? So 1 can be a factor. So I'm going to factor out a positive 1. And that's going to leave me with 4a minus 3. All I've done is factor out a positive 1. Why did I even do that? Well, there's a reason, and you're going to see right now. So now I can see that both of these have this in common. I can now factor out a 4a minus 3. And what does that leave me with? 3a squared plus 1. Because I factored out the 4a minus 3, I factored it out from 3a squared, and I factored it out from 1. Why does this make sense? Well, assume this is an x, and this is x. Assume it's not 4a minus 3. Assume this whole thing is an x, and this whole thing is an x. What would I do for each term? Well, I could factor out an x, right? So I could factor out an x and be left with this. You're doing the same thing, except you're factoring out a whole binomial. So let's try another example. This is the answer that you get here. Let's look at another example. All right. I'm going to go ahead and group this way, just because it's written that way, and group that way. Now let's do my greatest common factor. What can I factor out between 2p cubed and 5p squared? Well, no numbers, no constants, because 2 and 5 don't have any common factors. But I can factor out a p squared. And that leaves me with 2p plus 5. Because if I factor a p squared out, that leaves me with 2p and 5. So let's come over here. What can I factor out of positive 6p and positive 15? And the signs are going to be important. Well, that's a positive 3. If I factor out a positive 3, that leaves me with 2p plus 5. And that's my desired result, because now what can I do? I can take these, I can take 2p plus 5, and I can factor it out because both of them have it in common, and that leaves me with p squared plus 3. So we're using grouping right now to factor all of these. And sometimes grouping is easier in certain expressions than it is in others. So let's move down and let's look at something where we might have an issue. And let's look at 8. So let's look at 8. 8 looks pretty ugly. Well, as it is, I would group it like that if I'm going left to right. So let's try this out and see if this works. Is there a GCF between 224 and 56? Ouch. Well, if you actually look at these two, you can factor out a 56. 56 actually goes into 224 4 times evenly. And again, this is something you would have to piddle with on your calculator to find the greatest common factor. Between AZ and AC, they both have an A. I can factor out the A. So that leaves me with 4Z plus 1C. Again, I factored a 56 out. 56 goes into 224 4 times. So now let's go to the red. Well, I want you to pay careful attention. What am I looking for here? I want a positive plus a positive. Do y'all see that? 4Z plus C. Remember going back to our other examples, what do we notice about our terms? They match. 4A minus 3, 4A minus 3. 2p plus 5, 2p plus 5. They match. Well, in order for these guys to match, I have to have a positive plus a positive. So let's carefully examine these two terms. Well, 21 actually goes into 84 evenly, 4 times. But if I only factor out a 21, that's going to leave me with a negative minus a number. So how do I make both of these negatives into positive numbers? I actually am going to factor out a negative 21. And what do these two have in common? They both have a y. So I'm going to factor out negative 21y. Now watch what this does. What's a negative 84 divided by a negative 21? Positive 4, and I have a z. Do you see how that becomes positive? What's negative 21 divided by negative 21? Positive 1. And then I factored out the y, so I'm left with c. Now you can see that these two match nicely. So now I'm going to factor out 4z plus c from 56a minus 21y. And that is my answer. Again, you can see how this works. What if I wanted to take a quicker route, though? Do you see any common factors between 224, 56, 84, and 21? Probably one that's not immediately obvious. But in fact, 7 goes into all of these numbers. So what if I would have taken the 7 out first? Okay, I'm going to cross this out because we're not going to use this. So I'm going to divide all of these by 7. So how many times does 7 go into 224? Actually, 32 times. Now remember, I'm going to factor this 7 out, but I'm not going to forget about it. 32 AZ. How many times does 7 go into 56? 8 times. 8 AC. How many times does 7 go into 84? Obviously not that many that I have to draw a number like that. So 7 goes into 84 12 times. So I have minus 12yz. And 7 goes into 21 3 times. So I have minus 3yc. Now, if you recall in the AC method video, we factored out our GCF first, and then we did the AC method. Well, here I'm going to factor the 7 out. Now I'm going to group. But remember, the 7 can't just disappear. So let's group. I got these two guys, and I got these two guys. So my first ones, what goes into 32 and 8? 8 does. So I can factor out an 8a here, and that leaves me with 4z plus c. Now the same thing, I want to get matching positives, so I'm going to factor out a negative 3 here. Oops. Hold on a minute. A negative 3, and I'm also going to factor out a y. So that leaves me with 4z plus c. So the 7 stays, and I'm now going to factor out the 4z plus c. And that's going to leave me with 8a minus 3y. These two are one and the same. How is that? Well, let's examine this right here. What could I factor out of 56a minus 21y? A 7. So if I wanted to rewrite this, I could actually say this is 4z plus c. I can pull the 7 out of here, and the 7 can go in front. Remember, multiplication is commutative. I can multiply in any order I want. And that leaves me with 8a minus 3y, which is the same. So it's always easier if you factor the greatest common factor out first. So that's the way you factor by grouping.